Good evening, friends. Now, next topic we will discuss about the electronegativity. What in periodic properties? Last concept is electronegativity. Electronegativity. What is meant by electronegativity? What is meant by electronegativity? What is electronegativity means? Tendency of an atom to attract shared pair of electrons in a covalent bond is called electronegativity. What is electronegativity means? The tendency of an atom to attract shared pair of electron in a covalent bond. For example, if you take hydrogen fluorine, this is the covalent bond. This electron attract towards the fluorine from hydrogen. That's why this fluorine has more electronegative compared to hydrogen. Hydrogen is less electronegative compared to fluorine. This electronegativity is a relative property. This point must you have to remember. This is not having any units. Why? Because this is a comparison, relative property. It is not a like electron affinity. It is not like that. This is having comparison and also relative property, not the having the units. What is the definition? Tendency of an atom to attract shared pair electrons towards itself in a covalent bond is called as electronegativity. If in case of HF, if you take any HCl, here also chlorine is more electronegative compared to hydrogen. Why? Because they attract the electron towards the shared pair of electron in a covalent bond towards the chlorine side. This is the electronegativity definition. What is the difference between the electron affinity and electronegativity? I have to remember 1-2 points. Electron affinity is the accept electrons, but this is attracts electron. This is acceptance of electron. This is attract of electrons. This is having highest is chlorine in the periodic table. This is having fluorine. What is the main difference between these two is in general concept. If a man loves a woman, but a man love and marriage woman. This if it is only loves, it is electronegativity character. If it love and also it is married that woman, then it is called as electron affinity. This is the main difference between the in general concept I have explained. This is the easy, you can by explaining this you can understand easily. That's why I told. Only acceptance of acceptance and love and acceptance. This is called as electron affinity. It is electronegativity. This is having a units kilocalorie or kilojoule per mole. Kilocalorie per mole. But in this case, no units. Why? Because this is a relative property. It is a comparison, not having units. Third point is this is an isolated atom. This is the atom property. Isolated and a single atom. But it's in a covalent bond. In covalent bond only this will show electronegativity character, otherwise it is not shown. These are the some of the concepts I have discussed regarding electronegativity. What is electronegativity? Tendency of an atom to attract a shared pair of electrons towards itself in a covalent bond is called as electronegativity. Electronegativity is a relative property. If you compare it to two atoms, HF, fluorine is having more electronegative compared to hydrogen. It is a relative property. What is the difference between electron affinity and electronegativity? Electron affinity is acceptance of the love and acceptance of the electron, but electronegativity is attraction, not having acceptance. It is having the units, but it is a relative property. It is exists in the isolated gaseous atom, but this is exists in the covalent bond. This much you have to remember in case of electronegativity. Next, we have to discuss about the factors which affect the electronegativity. Factors affects electronegativity. For example, first is atomic size. If you take size is increases, what will happen? Attraction decreases. Attraction decreases means automatically electronegativity also decreases. Electronegativity is inversely proportional to atomic size. This is you have to remember. Next, second concept, nuclear charge. What will happen? Nuclear charge is directly proportional to electronegativity. Why? Because if charge is more positive charge, more will be the attraction. That's why this is having nuclear charge is directly proportional to electronegativity. Third concept is charge of cation. If cation charge is more, for example, m plus 1, m plus 2, m plus 3, what will happen? Automatically electronegativity increases. If charge on anion, what will happen? A minus, A2 minus, A3 minus, already having negative charge, by attraction of electron will be, because due to repulsions very less, smaller charge will be having more electronegative, decreases. A minus is greater than A2 minus is greater than A3 minus. In case of m plus 3 is greater than m plus 2 is greater than m plus 1. This is the concept. Charge of the atomic size, what will happen? Nuclear charge in case of charge on cation, charge on anion. This is the concept. Next we have to discuss one more concept is hybridization. This is one of the very important in the hybridization. In hybridization, percentage of S character increases, electronegativity will increases. For example, Sp, Sp2, Sp3. Percent of S character is 50%, 33.33%, 25%. Sp is more electronegative compared to Sp2 compared to Sp3. This concept also have to remember. This is one of the important concept. Next, these are the factors which affect the electronegativity in the periodic table: atomic size, nuclear charge, charge on cation, charge on anion, hybridization. Next, we will discuss the trends. Trends in the how it change in the period and groups. The electronegativity, how it will be changed in the periodic table in periods and groups. First, trends. Let me discuss trends. For example, if you take period, in period, what will happen left to right? Nuclear charge will be increases, the electronegativity will be automatically increases. For example, this is the in the period. That's why if you take from left to right, that's why fluorine is having highest electronegativity in the entire periodic table. Entire periodic table, this is fluorine is having highest electronegativity, that is 4. what will happen in the groups? In groups, down the group, electronegativity will be decreases because size is increases, auto electronegativity is decreases. If you take for example some of the concept of period 1 is hydrogen, period 2, what will happen? What are the carbon, nitrogen, oxygen and fluorine? Just easily remember. Next, chlorine, bromine and iodine, oxygen, sulfur, next nitrogen and phosphorus. These some have to remember. This is having 4, paste, oxygen having 3.5, this is 3, this is 2.5, 0.5 increase. Chlorine is 3, this is 2.8, this is iodine having 2.5. Next, sulfur is 2.5, this is 2.1, this is 2.1. You have to remember. फोन FON caliber में ISC में pH चेक करा. Fluorine is having 4, 3.5, 3, chlorine having 3, bromine having 2.8, 2.5, 2.5, 2.5, ISC, pH 2.1, 2.1. This you have to remember. फोन caliber चेक करने को ISC means इंटरनेशनल स्टैंडर्ड में pH हो गए 2.1. This you have to remember, general concept. From these element you have to by heart. Definitely based on this we get the questions. Must you have to remember. This is carbon, nitrogen, oxygen and fluorine. By starting fluorine, 0.5 will be decreases, then we get the 2.5, 3, 3.5, 4. From fifth group, 3, 2.8, 2.5. This you have 1 decreases, after that 0.2, 0.2. Next, sulfur is 2.5, phosphorus is 2.1. Phosphorus and nitrogen will be equal, then it will same. You otherwise you have to remember फोन caliber में इंटरनेशनल स्टैंडर्ड के लिए pH के लिए चेक करने के लिए आए. F fluorine is 4, oxygen 3.5, nitrogen 3, chlorine 3, 2.8, 2.5, 2.8. This is you have to remember. Must to remember. Some of the questions will get from by using these electronegativities. Based on these electronegativities, definitely we get the questions. Next, we have to remember scales for measuring electronegativity. First one is Pauling scale. Pauling scale. This you have to remember. Xi A minus Xi B is equal 0.208 on the square root of EAB minus under root EAA and EBB into Xi A means electronegativity of A. Xi B means electronegativity of B atom. Energy of AB, energy, bond energy of AA, bond energies. These are bond energies. This is bond energy of BB. This is units in kilocalorie per mole. This you have to measure in the kilocalorie of mole. In case of kilojoule per mole, we have to. In case of kilojoule per mole, just you have to change here is 0.1017. This is kilojoule per mole. To get the answer. Same the equation, but in case 0.1017, then we get the kilojoule per mole. This is in kilocalorie per mole. By knowing these electronegativities, by given in the question bond energies, we have to find out the given one electronegativity. You find out the other electronegativity atom. If anyone is missing, they will give the find out those measurement by using this. You can calculate easily. Factors, scales for measuring electronegativity. If by using A or B, by they given the bond energies, they find out the electronegativity of A, electronegativity. They given one of the electronegativity of B, then they will ask the question of the electronegativity of A. If they given A, given bond energies, we have to find out the B. In given in the kilocalories, we use this equation. If the same equation, but 1017 in case of kilojoules, we use this one. This is the Pauling scale. Next we have to Mulliken scale. Second one is Mulliken scale. Mulliken scale. What is Mulliken scale? The average of electronegativity is equal to average of electron affinity and ionization energy by 2. The average of these two plus this is called electron volt per atom. Electron affinity and ionization energy by 2. That is called as electronegativity of any atom. This is the Mulliken scale. You have to remember. This is next. We have to, in case of electronegativity, we will discuss. Next, last one is applications of electronegativity. Applications of electronegativity. What are the applications? Applications of electronegativity. First, nomenclature. Nomenclature. If you take HF, if you take HCl, if you take PCl3, if you take ClBr. In case of more electronegative atom, suffix used as ide. Suffix end with ide. This is hydrogen is 2.1, fluorine is 4. Then we call it as hydrogen fluoride. Not we call fluorine hydrogen. In case of hydrogen 2.1, fluorine is 3.5. Fluorine is 3. Hydrogen chloride. Hydrogen chloride. In case of phosphorus is 2.1, chlorine is 3. Phosphorus trichloride. In case of chlorine is 3, bromine is 2.8, which bromochloride, because not chlorobromine. Ide is suffix with more electronegativity atom. Bromochloride. This nomenclature you have to remember. Next, second application is, what is second application? This is the first application, nomenclature. First, second applications of percentage of ionic character. Percentage of ionic character. How you calculate the percentage of ionic character? This is very important. If you take this is HCl, HBr, these are the covalent bonds. The definition only we discussed. These are the covalent bonds. But due to electronegativity, they will get the partial negative charge and partial positive charge. Some of the ionic character must be there in every covalent bond. That's why they have asked the percentage of ionic character. How you calculate the percentage of ionic character? Definition is, one is the, you have to remember 16 delta x plus 3.5 delta x whole square. This we have to remember. Delta x is equal, this is the percentage of ionic character. This must be remembered. 16 delta x plus 3.5 delta x whole square. 16 delta x plus 3.5 delta x whole square. Delta x is equal to xi A minus xi B. This is electronegativity of A, electronegativity of B. The difference between these two is called delta x. 16 delta x plus 3.5 delta x square. That is called as a percent. Then we calculate the percentage of ionic character. For example, if we take HF, hydrogen fluoride, this is 2.1, this is 4. Total difference is 1.9. The by put it here, 16 1.9 plus 3.5 into 1.9 whole square. approximately you get the 43%. 43. This way the percentage of ionic character in HF is 43. This is the one of the application of the electronegativity. First application is nomenclature, second one is electronegativity, percentage of ionic character. Then we measure HF, HCl, whatever the compound they given, then we calculate easily. 16 delta X plus 3.5 into delta X whole square. That is called the next bond strength. Third one is bond strength. Bond strength is directly proportional to difference of electronegativity. This is also one of the important concepts we have to remember. Bond strength is directly proportional to difference in electron. If it is more difference in electronegativity, more will be the bond strength. For example, if you take HF, HCl, HBr, HA, which will having more bond strength, more strong. This is because this is hydrogen is 2.1, fluorine, that is get 1.9. Hydrogen is 2.1, carbon, this is how much? 0.9. Hydrogen is 1, 2.5, 2.1, 2.5, 0.4. Bromine is 2.8, 0.7. Hydrogen is 2.1, this is 2.5, 0.4. Which will be the more stronger one? That's why this is a strong bond strength. Strong bond strength means this is easily break and it will give easily H plus. This is strong acid, not the HF. This is the strong acid. This is the weakest acid. This is one of the acidic character. This is one of the concept. Acidic character is reverse, but bond strength consider this is stronger bond, less. Least bond means this is easily break and we will give the H plus gas. That's why is H plus donor is acidic, is stronger acid. This is one of the concept. Next, metallic and non-metallic character. Metallic and non-metallic nature. If more electronegative means non-metal. Less electronegative means it is having metallic in nature. Non-metal means will more electrons attracts the more. Metal means electron attracts less. Already metal में electrons will be there, but it is less attractive. This is one of the concept. Metallic based on electronegativity, you can identify metallic, non-metallic nature. Next concept is very important. This is acidic and basic nature. Based on that, which one is acid and which one is base? This concept is must you have to remember. How it will happen. Acid and base. For example, if you take sodium NaOH. For example, you take HNO3. How you write it? Nitrogen, oxygen, hydrogen, double bond, OH. This is the HNO3. HNO3 means this is O minus. This is nitrogen plus. Get nitrogen plus. Nitrogen is non-metal. Sodium is metal. Which bond will be break? Either this bond will break or this bond will break. Generally metals will give OH minus ions, basic nature. This is non-metal. Which one is? This is oxygen is 3.5 electronegativity. This is 2.1. Sodium is less than 1. If the electronegativity difference electronegativity 1, difference electronegativity 2. If these two electronegativity difference will be more less compared to this one, that's why this will break this one only. Difference in electronegativity 1 is less compared to difference in electronegativity 2. That's why they break the OH minus ions. But in case of nitrogen, how much is this? Is electronegativity 3, 3.5, 2.1. This is 0.1. This is how much? 1.4. This electronegativity. That's why this is donate the H plus ions easily. OH minus will be give release the OH minus means this is the base. Is donate the H plus means break the H plus means acid. Based on this, you can identify the application of electronegativity, acid or base. You can give any compound, you can identify it. Take for example X, O, H example. Either break here or either depends upon the electronegativity of X. Based on the electronegativity of X, either we break this one or this one. The difference between these two is more compared to the difference between these two. Definitely this will give the OH minus answer. If it is compared to these two, this difference is more, definitely they will break and give the H plus answer. H plus answer means acid, OH minus will give the base. Based on the difference between the electronegativity differences, we can identify it is acid or base. This is the about the electronegativity. Thank you.